7.5, comma, negative 7.2. And here is the polynomial. Now we did one of these last class, but instead of having a graph, in the last class we were told, okay, your zeros are this, and your zero is this, and your zero is this, and then we worked our way backwards. Instead of being told what the zeros are, we have to read them from the polynomial. So based on this graph, did I turn off half the lights in this room, or maybe this way? Let me try, because it's hard to read that graph with all the lights on this way. Nope, nope. How about that one? Okay. So now I know it's on the yellow. So, looking at this graph, what appear to be the zeros of this polynomial?
Negative 3 and 2.
Negative 3, 0, so x equals negative 3. And what?
2.
0.
And x equals 2. I'm told it's a third degree polynomial. How many zeros should I have? I should have 3. Where's the other one? So I got to vote for x equals 2. Why? Because it bounces. That's a good description. Anytime you see a 0 where the graph goes to that point on the x-axis and then turns around and goes back in the same direction, that is an indication that that is a 0 of an even multiplicity, either 2, 4, 6, 8, etc. In this class, we're going to assume they're all 2, because the only way to distinguish between them is how narrow the graph is when it bounces back. And if you have nothing to compare it to, you can't tell if it's narrower or less narrow, so we're going to assume they're all 2. So this is a fruit of multiplicity 2. That means I will need to write it twice when I'm writing down my zeros. So now, I'm set up just like the problem that was all written down where it said here's a 0, here's a 0, here's a 0, here's a 0, and then I got a point that I go through. What do I do now? What's the next step in working my way to finding the polynomial? Yeah, move everything over so that each piece is equal to 0. So I'll have x plus 3 equals 0. I'll have x minus 2 equals 0. And I will have x minus 2 equals 0. Now I put them together and multiply them. Say, okay, I'm ready. Here's my polynomial. I always throw in an a when I start my multiplying, because in the process of finding the zeros, I could have divided out a number which would have been my leading coefficient and lost that information. So I put it back in here. So I'll have x plus 3 times x minus 2 times x minus 2. How do I figure out what a is? What? Plug in the point. I plug in 5 for x. I plug in negative 7.2 for f of x. So I have negative 7.2 equals a times 5 plus 3 times 5 minus 2 times 5 minus 2, which will give me negative 7.2 equals a times, and if you multiply all these out, it's 8 times 3 times 3, which is 8 times 9, or 72. So if I divide negative 7.2 divided by 72 is going to be my a. So now when I write my polynomial, f of x, I put in my number for a, which turns out to be?
Negative 110.
Yeah. Negative 1 over 10. You don't have to simplify it if you don't want to. Times x plus 3 times x minus 2 times x minus 2, which you could just write as x minus 2 squared if you want to. You don't have to do that either. You can write both of them out. Now, if you've looked through the homework, the next problem looks very similar, except it's a fourth degree polynomial picture. This was number 8. No. Yes. 9. It's number 10. That's fourth degree polynomial picture.
Something you said one more time, right?
Yes, so it's just one more term.
Can you explain again how you knew that it was x equals 2 equals 3?
When you see a graph that looks like this, that's an indication that that is a root of multiplicity in all our graphs will be multiplicity 2. It could be multiplicity 4. If it goes through, then it's just a single root or a triple root, but it would have an odd multiplicity. But when it's got an even one, it hits and comes back. It looks an awful lot like a quadratic sitting on the x-axis. Now, one of the best parts that I like about this kind of problem is I can easily check to see if my answers are right. All I have to do is pull out my graphing calculator, type this in for y1, and set my window to look just like this one, to go from -6 to 6, and from -3 to 1, and it should produce exactly that graph. And if it doesn't, then I made a mistake somewhere. If you can pretty much tell if your places where it hits the x-axis are wrong, then you must have done something wrong when you were moving the axis, when you were setting things equal to 0. Usually you messed up the sign there. Or if it turns out to be flipped over, then chances are you missed the negative that was supposed to be there, or put in a positive where it was supposed to, a negative where it was supposed to be positive, or positive where it's supposed to be a negative. But you can always check these by graphing them on your calculator.